desert river, its verdant banks bursting with new vegetation. A sea of sand dunes, blanketed with fresh snow. A mountain, its sides dazzling with the arrival of autumn's foliage. Images that not only capture the imagination, but, more importantly, tell a story. A story of our planet's surface, ever evolving, a patchwork of rivers, mountains, deserts, oceans, farmlands, and cities. A story told over the course of days, months, years, and decades, all thanks to the Landsat program.
Landsat actually was one of the things that first got me involved in remote sensing. Landsat provided that global perspective, but still at the management scale resolutions, plot level, field scale, but also provide that sort of whole Earth scale resolution, and that was pretty exciting.
For over 50 years, Landsat has watched over Earth, giving us critical insights into the way our planet is changing with us and around us. Now, 8 satellites later, it's time for this story's next chapter. Landsat Next. The next phase and the longest space-based record of Earth's land surface will provide a host of new capabilities for the next generation of Landsat data users, including enhanced spatial resolution and 15 new spectral bands. But the most remarkable feature of this new mission, while previous Landsat missions have all featured one satellite, Landsat Next will be a trio, a constellation of 3 observatories circling the globe in unison.
Even before the launch of the last Landsat, the user community was actually being queried about what was their needs for the next Landsat. One of the things that came back was all the users said higher temporal revisit was the highest thing that people were looking for. And the way you get higher temporal revisit is you either have a wider swath so that you have a wider field of view, or you have more satellites that are viewing a larger portion of the Earth all the time.
We came up with this approach that utilizes 3 smaller observatories to meet that temporal revisit and incorporates those spatial resolution improvements at each observatory while maintaining the full spectral capability across each observatory.
This new triplet configuration will greatly improve the temporal revisit time, from 16 days with Landsat 9 down to just 6 days. Landsat Next will give scientists and data users a more precise view of how a scene changes over time. This can help highlight key stages of plant growth and is useful for crop management and estimating yield.
One of the criteria actually we use to assess just even types of cover is based on when the crops emerge, when they might be harvested, but also being able to look at different insect outbreaks, look at different effects of drought. All this stuff can happen very fast, and so being able to respond quickly, this is an important aspect of being able to have this higher temporal revisit.
Throughout the program's history, Landsat satellites have been able to chronicle the surface of our planet in stunning detail. Landsat Next will look to push that capability even further. To understand the resolution of Landsat, we need to zoom all the way in until we see individual pixels. Each pixel of a Landsat 8 or 9 scene is about 30 square meters. Landsat Next looks to improve this to 10 meters, roughly 9 times the resolution, allowing us to pinpoint finer details within the image.
This is fantastic. So now we'll be actually picking up about 40% more agricultural fields that we totally missed before, and that's just in the US alone. So some of these smaller agricultural fields, windrows, crevasses, and ice fields, those will be picked up in new Landsat data.
This enhanced spatial resolution won't be limited to just visible light. Thermal bands will also be getting an upgrade from 100 meters to 60 meters, a resolution dimension slightly larger than the bottom of the Statue of Liberty's pedestal. Urban areas like New York City are prone to suffering from a phenomenon called the heat island effect, as an excess of impervious surfaces absorb and re-emit the sun's heat. Using Landsat Next's improved thermal resolution, scientists and data users will have the ability to map the temperature of urban areas in finer detail, possibly shedding light on better methods of sustainable urban development. Landsat imagery is well known for the vivid detail it provides of the Earth's surface, but Landsat satellites are actually collecting data from across the spectrum, starting with 4 spectral bands with Landsats 1 through 3, up to 11 bands with Landsats 8 and 9, from visible to thermal infrared. Landsat Next looks to push the program's spectral capabilities even further, boasting an additional 15 spectral bands, bringing the total to a whopping 26. With more than double the spectral bands of Landsats 8 and 9, users will be able to glean even more information from Landsat Next data, allowing for better resource management, such as tracking water quality and detecting harmful algal blooms.
Coastal waterways, we're experiencing algal blooms like never before. Those are health concerns for our population. Being able to detect those and respond to them quickly, that temporal revisit and those new bands enable us to do that.
The other thing is actually being able to better track dynamics of snow and ice. The melting snow and ice are used to recharge water sources, especially in the western U.S. So being able to know when those resources are going to be available, determining potential for flooding versus recharge is very important for water management.
It's often said that Landsat's superpower is time travel, granting its users the ability to rewind the clock and observe the evolution of our planet's surface during the last half-century. But the true key to unlocking Landsat's ability to travel in time has been the remarkable consistency in data quality across multiple decades in Landsat missions.
It's more than that, actually. It's a time machine, but it's also a time and space machine, I would argue. It's not only being able to look back into time, I think it's also being able to look at different places on the globe and give you a consistent picture anywhere on the globe as well. And that's what Landsat allows us to do. There's a consistency in the measurements, there's consistency in the way the instruments were calibrated. The reason why this is so important is that changes on Earth, whether they be changes in vegetation or subtle changes on the Earth's surfaces, that we want to make sure that we're actually capturing these changes and they aren't just changes in the instruments themselves.
Landsat has been historically the gold standard reference for calibration of many different missions across the whole globe. The radiometric quality for Landsat Next will be at least as good as any previous Landsat, so we will maintain that standard for calibration and referencing for all missions.
Landsat Next's 3 satellites, improved 6-day temporal revisit, enhanced spatial resolution, and 26 spectral bands all add up to a massive amount of data. Landsats 8 and 9 each record around 750 scenes per day. With Landsat Next's trio of satellites, that number will skyrocket to over 2,200 scenes per day. More scenes means more data.
This will be a huge increase in data volume. This means we're not going to be downloading data anymore. Get ready to be doing all your data processing in the cloud.
Mission data volume and management is our #1 challenge on Landsat Next. Once we get that data to the ground, our partners at USGS, who operate the ground network and ground systems, they can handle that transmission and then publish it and provide it to the cloud for all these users to have free and open access to this data. I can't stress enough how exciting that is for any small university to be able to sign up and tap into that data.
It's still early days for the Landsat Next mission. Slated for launch in late 2030, there's no shortage of work to be done over the next 7 years. But plans for the new triplet constellation, upgraded spatial and temporal resolutions, and added spectral bands have the Landsat Next team excited.
Our mission right now is really a quantum step forward from previous Landsats. This may be the biggest leap in capabilities since the launch of Landsat 7. And when we launch in 2030, it'll be the biggest improvement in 30 years. I'm very, very excited. I can't wait to see what comes out of all of these emerging applications and how well it supports the user.
Over the life of the Landsat program, the world's population has more than doubled, leading to increasing pressure on precious resources such as food and water. But time and time again, Landsat missions have only served to highlight humankind's innate ability to adapt to its environments, enabling us to develop better methods of sustainable resource management. by helping farmers to monitor the health of their crops and efficiently manage their water resources, by guiding forestry management programs on better ways to identify areas at risk for wildfires and track changes in land use over time, or by contributing to conservation efforts, monitoring and assessing the biodiversity of coastal wetlands and protected areas. Landsat Next will look to not only preserve this over 50-year legacy, but bring it into the future.
We live on this planet Earth. We all know that we want to leave this planet for our children. We know the importance of sustainability, and I think that's what Landsat's all about. It's about helping us manage the planet that we live on for the long term. And that's why it's there, and that's why it continues to be here, and I expect it to be there for the next generation as well.